Right, I'm back again. This time around, you're on the third question. We just want to investigate if there's still similarity. Oh, it looks like we're sitting around the same thing because I can see P and Peter there. Let's try and check again. We're interested in the components. Components. Let's see if I can pick my pen. Right, so let's see. Now, yeah, my pen. So interested in what's happening in the X and in the vertical, which is Y. This problem has to do with equilibrium. Now, we have four planar forces there of magnitude 8, 12, 10, and P. They actually want to point in the directions given. So we're interested in finding the value of P and theta. So let me break down my page so that we move in synergy. We don't want to lose calculations. So this side lets me have what's happening in the X. Well, in the X, I've got this force, so we know we need an equal sign here. So this force is 12, so we're going to have 12 plus, well, here we have this component, it's another X coming from the 8 Newton force, so it's going to be 8 cos 30 degrees. When I move to the left, which will be before the equal sign, so I'm moving this way. We've got a force here with magnitude P, but I'm interested in the adjacent, so it's going to be P cos theta. And there is another one here of magnitude 10 newtons. It's adjacent relative to angle 45. So you have 10 cos 45. Let me quickly do the y. Y is the vertical. So above the equal sign where we need to be after above the horizontal way, we know it will go after the equal sign here. I've got two components, one on the 8 newtons and the other on the P. So let me start with the 8. Yeah, because we're not going vertically, it's a right angle triangle between the opposite side, which has to do with sine. So I'll be having 8 sine 30 degrees plus, when I look at P, it's in terms of angle theta. So that will be P sine theta. And step carefully, I can see 45 here, I can see 30. Those are special angles. And like we did last time, I'm not done with what's below. If I go below the equal sign, I'm only seeing the 10 Newton vector at an angle of 45 degrees. So I'm going to say this side is 10 sine 45 degrees. Well, this one here does not have the y component. So now I'm moving to simplification. Like I was saying, with 45 degrees, you have 30. So when I simplify, I need to make P subject the formula. Why? Because there's P together with cosine. And the only way in which can easily eliminate one is to bring in the identity tan theta is equal to sine theta of cos theta. So let's see how we bring it. We'll be forced to transpose what we have here, which is 10 cos 45. So as I'm doing the calculation, it will be P cos theta being equal to here I have 12 plus 8 cos 30. But this one only transpose it becomes negative 10 cos 45. Still continuing with the simplification because I have special angles here. So it will break down to cos theta here, 12 plus, well, cos 30 gives us root 3 over 2. Root 3 over 2 times 8. So it tends to be 4 root 3. So let me probably write my 3. Then we have cos 45 there. Cos 45 is the special angle, which gives us root 2 over 2. But there's a 10, so to multiply 10 with root 2 over 2, it simplifies it to minus 5 root 2. Then with the first equation in terms of x, we are moving to the right hand side. Well, the right hand side, we are being forced to transpose this to the other side so that we have p sine theta is subject to formula. But I'm going to replace on the equal sign because I want the unknowns to be on the same side of the equations. So when I do so, I'll start with p sine theta being equal to, because I'm going to transpose 8 here. So on the right hand side, nothing changes, which is now currently the left hand. We have tweeted, so that's 10 sine 45 degrees. So the one that we move, it will change the sign to 8 sine 30 degrees. So let me try simplify because I can see special angles there. So it's p sine theta being equal to sine 45, which is the same as cos 45, that's root 2 over 2 times 10 gives us 5 root 2 minus Sine theta. Sine theta was special again, which gives us half. Half times 8 gives us 4. Now I've got my two equations, which are similar to the ones that we saw earlier. I can align them one above the other so that I can bring the identity term. Let's see if it can work. I'll start with P sine theta being equal to 5 root 2 minus 4. So below, I'll divide by the same thing, both days equality then, which will be P cos theta. And the other side on my denominator will be 12 plus 4 root 3 minus 5 root 2. So as I proceed with simplification, it looks like the p's are appearing on the imaginary denominator, so it eliminated them. Then I have the identity sine theta over cos theta, which will simplify to tan theta being equal to the expression that I have, which I believe our scientific calculators can easily simplify. So we just make sure we do proper substitution or proper punching into our calculator so that we don't get a wrong solution after all these steps of solving the problem. So that's minus 5 root 2. Let me try and bring my calculator. This is my calculator here, and my interest is to punch this. But the idea would be, it would be nice if we punch it after having made our theta the subject. So if we are saying theta here, theta will be equal to arctan of, I'll bring a bigger bracket, 5 root 2 minus 4, all over 12 plus 4 root 3 minus 5 root 2. We close the brackets. Then perhaps I can now bring my calculator to say the second function, tan. And then I open the brackets on my numerator like the CIE 5 root of 2. I move out of the root sign. There is minus 4. I close the brackets. Now I'm going on the denominator where I might need to open the second bracket. Let's see, why is my delete not removing? Then I'll have to restart the calculation and to say, let's see. We want to reset it. So let's see. Let's see. Now it's fine. So I'm going to say second function tan. I open bracket. I open another one for the numerator. So that's 5 root of 2. I move out of the root sign. Minus 4. I close the first bracket for the numerator. Then I move to the denominator where I'm having 12 plus there's 4 root of 3. I move out of the root sign. There's minus 5 root of 2 coming from the special. I close the denominator bracket and the overall bigger one. If I say equal, then I have the value of theta is 14.5. So my theta is 14.5. When I go down the page and conclude that now my theta is 14.5. Because theta is an angle that will be in degrees. So like we did last time, the moment I have theta, I can pick any of the two, either the equation in terms of sine or the one in terms of cosine. Oh, I think the one in sine might be easier to work with because this with fewer terms. So when I bring it, this will be the picture. Let's try and see. We are saying P sine of, because I'm dealing with this equation, sine theta, but theta is not on here. So we are now substituting it. The sine 14.5 being equal to 5 root 2 minus 4. So when I make P the subject of formula, I'll be dividing both sides by sine 14.5 here, sine 14.5 degrees. So this side, we mentioned to the same cancel. I can now bring my calculator to say, for my top part A, I'm now saying if I want P was equal to, I can put it inside one bracket, say there's 5 root of 2. I move out of the brackets. minus 4, close the bracket, divided by, I have sine 14.5. Then I close my brackets equal to, means our P is actually 12.3 if we round to one decimal place. So I can just try write somewhere here to say P is actually 12.3. And remember, P is a force that will be in newtons. I hope you found this one interesting, but it looks like the themes are similar. We are bouncing around the identity tan theta being equal to sine theta over cos theta.